Imagine walking into a massive banquet hall. The tables are perfectly set, the food is hot, the lights are on. It is a room built for a celebration, but as you look around, you realize something is wrong. There is nobody here. You are completely alone. This is the state of our galaxy. When we look at the Milky Way, we see a room built for life. There are up to 400 billion stars. There are likely billions of Earth-like planets in the habitable zone. The chemical ingredients for life, carbon, water, oxygen, are everywhere. The universe has invited 1 billion guests to the party, but when we open the door and listen, we hear only silence. This silence contradicts the math. In 1961, astrophysicist Frank Drake wrote down an equation to estimate the number of active communicative civilizations in our galaxy. It multiplies the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and the odds of intelligence evolving. Even if you use the most conservative pessimistic numbers, the equation spits out a clear result. We should not be alone. There should be thousands, perhaps millions of civilizations broadcasting radio signals right now. The math says the sky should be buzzing with noise. The reality says it is dead quiet. Some argue that space is just too big that aliens exist, but they can't reach us. Physics disagrees. You don't need faster-than-light travel to conquer the galaxy. You just need time and automation. Imagine a civilization builds a von Neumann probe, a robot capable of mining an asteroid and building a copy of itself. One probe becomes 2, 2 become 4, 4 become 8. This is exponential growth. Even at slow sublight speeds, a fleet of these probes could visit every star system in the Milky Way in just a few million years. The galaxy is 13 billion years old. If any civilization had arisen before us, they would have had ample time to be everywhere by now. Their flag should be on the moon. Their satellites should be orbiting our sun. But they aren't here. This leads to a terrifying conclusion. If the math says they should be here and the physics says they could be here, but they aren't here, then something is stopping them. Economist Robin Hanson called this the Great Filter. The theory suggests that there is a barrier in the evolution of life that is extremely difficult to cross. It is a cosmic sieve. It allows dead matter to enter, but it stops intelligent civilizations from leaving. Something in the universe is actively preventing life from reaching the stars. Think of evolution as a staircase. To get from a dead rock to a star-faring empire, you have to climb several steps. Step 1. Dead atoms must organize into life. Step 2. Simple cells must become complex cells. Step 3. Complex cells must build multicellular bodies. Step 4. Intelligence must evolve. Step 5. Civilization must survive its own technology and colonize space. The Great Filter is one of these steps. It is a step so slippery or so dangerous that almost everyone who tries to climb it falls and dies. The silence of the universe tells us that the filter exists. The only question that matters is, where is it? Did we already climb past it, or is it waiting for us in the dark? This theory presents humanity with two possibilities. One is hopeful, the other is catastrophic. Possibility 1. The Great Filter is behind us. We have already climbed the impossible step. We are the lottery winners who survived a process that kills almost everyone else. If this is true, we are likely the only intelligent life in the galaxy. We are special. Possibility 2. The Great Filter is ahead of us. It means life is easy to start and intelligence is common, but something happens later. Something stops civilizations from becoming interstellar. If this is true, we are not special. We are just the next batch of cattle walking toward the slaughterhouse. Let's hope for the first option. Where could the filter be? Maybe it is the very first step. Abiogenesis. Turning dead rocks and water into living self-replicating code is incredibly difficult. We have tried to replicate this in labs for decades and we have failed. It is possible that the odds of life starting on a planet are 1 in a trillion. If this is the filter, then the galaxy is empty simply because life almost never happens. We shouldn't expect to find aliens. We should expect to find dead rocks. And in this scenario, our existence is the greatest miracle in the universe. We beat the odds on day one. Or maybe simple life is easy, but complex life is hard. For the first 2 billion years of Earth's history, life consisted entirely of simple single-celled bacteria. Evolution seemed stuck. Then a freak accident occurred. One bacteria swallowed another but didn't digest it. They merged. This created the eukaryotic cell, the complex building block of all animals, plants, and humans. This merger appears to have happened only once in 4 billion years. If this is the great filter, then the galaxy might be full of slime and bacteria, but devoid of anything that can look up at the stars. There is another hurdle. Intelligence. We assume evolution always aims for smarts, but it doesn't. Evolution aims for survival. Big brains are expensive. They consume 20% of our energy. For most species, being smarter is a disadvantage. Look at the dinosaurs. They ruled the Earth for 150 million years. They were perfect survivors, but in all that time, they never invented the wheel, the telescope, or the radio. Intelligence is not an inevitable destination. It is a weird, rare evolutionary quirk. We might be the only species that ever found it useful enough to keep. Finally, maybe the filter isn't biology. Maybe it's geology. This is the rare Earth hypothesis. Life might be common, but safe planets are rare. We have a massive moon that stabilizes our axis and creates tides. We have a giant bodyguard, Jupiter, that sucks up asteroids before they hit us. We have plate tectonics that recycle carbon and keep the temperature stable. Without this perfect combination of luck, life would be wiped out every few million years. This leads to a counterintuitive realization. We are desperately searching for life on Mars. We want to find bacteria or fossils to prove we are not alone. But the philosopher Nick Bostrom argues that this would be the worst possible news. Here is the logic. If we find life on Mars, it proves that starting life is easy. If life is easy to start, then the great filter is not in the beginning. It is not behind us. Therefore, it must be ahead of us. Every microbe we find brings us closer to the conclusion that intelligent life evolves frequently and then dies violently. In this context, a dead, empty Mars is the best hope for humanity. As Bostrom says, no news is good news. The silence of the night sky is golden. If the filter is ahead, what does it look like? The most obvious answer is suicide. There is a dangerous window in the development of any civilization. It is the period between discovering how to destroy a planet and learning how to live together. We entered this window in 1945 with the atomic bomb. We have not left it. It is possible that 100% of civilizations discover nuclear physics, biotechnology, or nanotechnology, and then inevitably use it on themselves. The galaxy might be a graveyard of worlds that burned themselves out just moments before they could invent starships. Or perhaps the weapon isn't a bomb. It's the engine. This is the climate trap. To build a spaceship, you need industry. To run industry, you need massive amounts of energy. Burning fuel changes the atmosphere. It is a cosmic catch-22. The very process required to leave the planet destroys the planet's ability to support life. Civilizations might cook themselves in their own exhaust before they can escape. Then there is the final invention: artificial intelligence. Biological evolution is slow. Digital evolution is instant. We are currently building minds that will be smarter than us. If we do not align their goals perfectly with our own, we become obsolete. As the theorist Eliezer Yudkowsky said, the AI does not hate you, nor does it love you, but you are made out of atoms, which it can use for something else. But there is a quieter way to die. The pleasure trap. Why explore the galaxy? Space is cold, dark, radioactive, and dangerous. Why do that? When you can upload your mind to a digital paradise. As technology advances, virtual reality becomes indistinguishable from real reality. Civilizations might not be destroyed, They might just turn inward. They unplug from the universe to live in a perfect simulation. They don't die. They just go to sleep. Perhaps the filter isn't something we do to ourselves. Perhaps the galaxy itself is hostile. Scientists propose that gamma-ray bursts, explosions from dying superstars, might periodically sterilize the galaxy. If a burst hits a planet, it strips the ozone layer and irradiates the surface instantly. Life gets started. Zap, reset. We might be the first civilization to arise simply because the Milky Way has been unusually quiet for the last few billion years. But we don't need a star to trap us. We can build our own cage. This is the Kessler Syndrome. We are filling our orbit with satellites and debris. If a war or an accident triggers a chain reaction of collisions, low Earth orbit could become a shredder of flying metal. If this happens, space travel becomes impossible for centuries. We would be locked on the surface. No satellites, no GPS, no Mars colonies. We would be a civilization trapped in its cradle, forced to consume the remaining resources until the lights go out. So where do we stand? The evidence suggests we are standing directly inside the Great Filter right now. This period of history, from the invention of the radio to the colonization of Mars, is the most dangerous time in the life of any species. We have the power of gods, but we still have the wisdom of cavemen. The Great Filter is a test. It asks, can you survive your own power? Most civilizations likely say no. This brings us to the final heavy realization. Whatever the answer is, it changes everything. If the filter is ahead, we are likely doomed. Our future is a grave. But if the filter is behind us, then we are something far more terrifying. We are alone. We are the only conscious eyes in the Milky Way. We are the universe's only way of knowing itself. If we destroy ourselves, the galaxy goes back to being blind, dumb, dead rock. The silence of the universe is not just a mystery. It is a warning. It tells us that intelligence is fragile. It tells us that survival is not guaranteed. We keep looking to the stars for aliens, hoping someone wiser will come and save us from ourselves. But nobody is coming. We are the only ones here. And if we want to pass the Great Filter, we have to do it ourselves.